Good morning all. Today we will be discussing a problem of infiltration. For a given basin, the following are the infiltration capacity rates at various time intervals after the beginning of a storm. Make a plot of F curve, that is we have to draw the Horton's curve and establish an equation of the form developed by Horton. Also determine the total rain and excess rain. So first step we have to draw the F curve, then we have to develop the equation. First we will go through the data. These are the data given. Time in minutes, then rate of precipitation and rate of infiltration. Data continues up to 30 minutes. Okay. So first step, you have to draw a graph. You have to draw a graph with time in minutes on x-axis and y-axis rate of precipitation or infiltration. If you consider the time and rate of precipitation, you will get a hyetograph. I am just drawing, this is not the correct values. I think you will get a graph like this if you plot rate of precipitation and time. Then if you consider rate of infiltration and time, you are going to get a graph like this. So first draw the graph, then we'll discuss the problem. This is the graph, time in minutes and precipitation, rate of precipitation or infiltration. If you consider the scale, x-axis represent 1 centimeter is equal to 2 minutes and y-axis 1 centimeter is equal to 1 centimeter per hour precipitation. Next we will consider, we have to use an equation, you have to create an equation for this F curve. This is the F curve for this one, we have to, or Horton's curve for this, we have to write the equation. So first you extend this curve to meet the y-axis. Okay. Then if you consider the equation Fp, this is the equation, Fp is equal to Fc plus F0 minus Fc e raised to minus kt. So what is Fc? Is the final infiltration rate or infiltration capacity. So this become horizontal after a particular time. So here this value represent Fc, and from this figure Fc is equal to 1.2 centimeter per hour. 1.2 centimeter per hour. So here Fc is equal to 1.2 centimeter per hour. Then F0 is the initial infiltration. So you are extending to get that value. So this represents F0. We have discussed already. So F0 is equal to, it is 4.5 centimeter per hour. Then next one, we need the value of k. How to get the value of k? F0 minus Fc divided by F. What is F? How to find out the value of F? This much area represent F, capital F. How to find out that area? So we are going to calculate the value of F. For that one, first I am going to consider this much area. The entire area it is, we have to consider small squares, small units, and we have to calculate the area. First I am considering this much area. If you look at the bottom, it is 8 minutes, and here it is, this is 1.2. So 2 minus 1.2, you will be getting it as area. I am going to calculate it is 0.8 on y-axis and 8 on x-axis. That you are getting in a different unit. Finally, we will convert that into a common unit. Okay, 0.8 into 8. Then next one, I am going to consider the square. So first one, this one complete square. Okay, then marking it as 1. Then if you consider this much area, you can take it as a second square. Then if you consider these two, approximately equal to the third square. Okay, so I got 3 square, complete square, approximately equal to 3 complete square. So I am writing here that value, that is, here it is 3 minus 2, it is 1, 1 into bottom it is 2, we have total 3 square. Okay. Next, here we have to measure this area. So first one, I am going to consider this area plus this one is approximately equal to area of this much. Okay, approximately equal to this much area. So that is equal to plus it is 0.8 into 2. Okay. Similarly, if I am considering this area plus this area, will get one more. Okay, one more 0.8 into 2. And next I am going to consider this area. Okay, this area, and then this much area is here. So I am going to consider this as a complete one, this much area. Okay, so I am totally getting 3 square. One is this red, then this black 2, then this one gives the third one into 3. 1, 2, 3. So you will be getting 17.2. Here the unit, upper one it is centimeter per hour into minutes. So in order to convert the minutes into hours, we are dividing by 60. So you will be getting 0.286 centimeters as rainfall. Hope you understood. And we got the area as 0.286 centimeters, and substitute the value of F0 as 4.5 minus 1.2 divided by 0.286, you will be getting a value 11.54. So the equation for FB is equal, F0 it is 1.2 plus 4.5 minus 1.2 into e raised to minus 11 into t. So this value is 1.2 plus 3.3 e raised to minus 11.54 t. This is the equation for F curve. Next you have to calculate what is the total rainfall. How to calculate total rainfall? Area under the hyetograph represents the total rainfall. Area under the hyetograph. So area equal to, if you consider this much value, it is 6 into 5 plus, then this much it is 16 minus 6, it is 10 into 6, this is 7.5, this value it is 7.5. So in the 7.5 plus this is 2.5, and 16 to 30 means it is, this value it is 14. So 14 into 2.5, so you will be getting 6 into 5, 140 total area divided by 60. We are converting that into hours. It is 2.33 centimeter. This is the total rainfall. Okay. Next one, excess rain, that is runoff, we have to calculate. This much value is infiltrating. Okay. This is the infiltration. We have to calculate the excess rain, that is, this is represent runoff. We have to calculate that value, runoff. So we already calculated this much area, and to that you have to add this area. You have to add this area. So that is, this is 1.2. So that area, it is 1.2 into total, it is 30 divided by 60, converting that into hours. Here time in minutes, okay, not in hours. 1.2 into 30 divided by 60. So I will be getting 0.6 centimeter. So total rainfall equal to 2.33 centimeter. Infiltration equal to 0.286 plus 0.6. So runoff, or we can call it as excess rain. It is 2.33 minus 0.886, 1.44 centimeter.